battery's charging, so onto the positive, pick up at the earth, good earth. It's sitting at 14.2 volts, so the alternator's definitely charging. Now I don't know if it's a smart charge on it yet, but the battery was completely flat, so we would expect it to be reading battery voltage being charged, which is at least 14.5 volts maybe, so we're not far off of that. So yeah, that looks like alternator's working okay. Right, so I'm taking off the battery cover so we can now see the negative lead, and as you can just see, it does have a battery monitoring sensor. So this car has smart charge, but as it currently now, that shouldn't be an issue because the battery's that flat, it should be straight on charge. Whereas with smart charging, if you've got a good battery, there's no drain on the car, then it could potentially sit anywhere from 12.5 volts to 15.5. So don't always expect a car with smart charging to be sitting at 14.5 all the time. But if you're ever unsure and sit at 12.5, turn heaters, lights on, and it should automatically jump up the charge voltage. But there you can see it there, look. There's the battery monitoring sensor on the end of the battery. So let's do a battery drain and see how much amperage is coming out of the car with the engine off. Right, so I need to switch our multimeter on to test for amperage. So remember, this one's quite decent in the fact that it tells you what leads you need to be on. So if I set the multimeter to 20 amps, it tells me that I've got to put one lead in the common and one into the amperage. So I take that lead out of here, the red lead, put it into this one here, which is maximum. This multimeter takes 20 amps, which is unusual. Your average multimeter only takes 10. So you're connecting this to the car, which you need to connect in series. Make sure you don't try and start the car because it will automatically blow the multimeter. This is only for doing a battery drain test. Right, so the way I've connected it, because this one's such a pain to get to the earth at the back, I've taken off the positive lead. So remember, it doesn't need to be the negative specifically because it's the same amperage that's getting coming through the positive as it is going back through the negative. So I've disconnected the positive lead. I've got a multimeter on amperage. I've got the black lead connected to the positive lead, which I've disconnected from the battery. And I've got the red lead onto the battery terminal, positive terminal. And just now we're drawing about 2.4 amps, which is really, really high. Now I've still got the key in the ignition, so I'll take the key out. We need to let the car go to sleep, and really we're looking for about approximately 80 to 100 milliamps, which means the very maximum which you see is a 1 on the second digit here. But just now we're drawing a huge amount of amperage off the car, but I can actually hear a solenoid buzzing in the background, so let's take the ignition key out and let it settle and see where it drops to. Now I've got the ignition key out, but look, you can see the car's still awake, because we've still got the parking light on, the parking brake light's on, and we've still got the parking brake light on in the middle of the console here, so we'll need to let it go to sleep. Now, we might end up having to lock the car up and latch the bonnet in order for that to happen. Let's just give it a couple of minutes and see what happens. Right, so I've latched the bonnet, and the car, it's been sitting for about 2 minutes now. And look, it's still nearly drawn about 2 amps. Which is way, way too high. It's about 10 times higher than the amount of amperage. It's not flicked up, it's dropped down a wee tiny bit there. Sometimes some cars can take a while as all the modules slowly start to switch off. But it's still sitting way higher. Now the battery's it's almost flat in this car because it's been sitting for a while. We've not let it charge right up. Dropping down a wee bit more, look. That might be just for the fact that the battery is that drained. But it's still way, way too high. So we need to figure out what is staying on and drawing the amount of amps that it is out of this battery. Left it for another couple of minutes. It seems to be sitting now around about the 300 milliamp mark, which is at least over 200 higher than it should be. So we definitely have a battery drain in this car. But how do we find that? Any suggestions, David? That'll be a no then. Right, where are we at? So far we've checked all the fuses in the glove compartment. Ideally you don't want to be pulling the fuses in and out, because normally when you pull a fuse out, essentially what happens is it kind of wakes the car up. even to a certain extent when you're checking the ones inside the car. As soon as you open the door, which I'll show you just now, we're at 0.03 or 30 milliamps. Now that has happened because we've found a fuse panel underneath the main fuse panel in the engine compartment, and there's a 30 amp fuse there, which you can see I've taken out, and it's dropped down to 0.0. The 30 milliamps is fine. I always say about 50 to 80, but 30 is even better, isn't it? Now, as soon as you open the doors or do anything, the car essentially will wake up and it brings it up to the 2 amps. So you need to let the car try to go to sleep. But let me just put this fuse back in and show you where it goes to when I put the fuse back in. Right, I've put the fuse back in. We're now at 150, 160 milliamps. Now the car is locked. The car essentially is asleep because we've left it for ages. As soon as I pull this fuse, 30 amp, drops down to 0.03. So the car is sleeping. Now when we check what that 30 amp fuse does, it says it's for a reductant pump, i.e. your AdBlue pump. This car doesn't have AdBlue on it, it's not a Euro 6. So we're just going to double check. What we're going to do is we're going to turn the ignition on, we're going to run a fault scan and see if it gives us any active codes with this fuse being out, to see if it's missing a reductant pump or a knock sensor. Give me 2 seconds and I'll let you see what the scan tool says. I stand corrected. This 2016 does have an AdBlue pump. Now there's the filler neck there, so I've lifted up the cover inside the tailgate at the back. Now the question is, I've just scanned the car with that fuse out and it hasn't brought any AdBlue faults up. So what we're going to do is we're going to build everything up at the front and we're going to double check it to make sure that, I'll just take you over to the scan tool. There's where we're at the moment. Look, no faults on it just now. So we're going to start the car, run it and see if we get any AdBlue faults. For all we know, this pump has been coded out of the car, hence the reason why there's no faults appearing. But let's double check. Right guys, I've started ignition, started engine 3 times, rescanned it, and there's no codes at all for AdBlue on the car. So I'm going to go back to the customer, explain to them it does look like the AdBlue pump is what's draining the battery down because it won't start in the morning. We don't know whether it's been coded out, so we just need to find a bit more information. But this has just been a quick video to show you how to do the parasitic drain on the batteries. Hope it helps. Bye. Now always remember, when you're finished doing any amperage checks with your multimeter, take that lead out of there, stick it back in there, just so that if the next check you're doing is a voltage check, you don't short either the meter or the component you're testing. So take it out the amperage, put it back in there.